Hi, this is Maharish Gaud and my teammate K. Ajay Chari. We are done with the project Turmeric Plant Leaf Diseases Detection and Classification using Deep Learning as minor project under the guidance of Ignatius K. Piyush, Assistant Professor, and we are from the Department of Computer Science and Engineering, School of Computing, and we are studying and pursuing BTech third year in Veldek Rangarajan, Dr. Shakundala and R&D Institute of Science and Technology. And here the certificate of our project, and we declared it, and this is approval sheet, acknowledgement, and now the abstract of our project is the ability to produce higher quality crops in prerequisite for any country's economic development. Many people are employed in the agriculture sector, which makes for a significant amount of gross domestic product in many nations across the world. As a result, detecting illness in plants at an early stage is critical for increased agriculture productivity. Bacteria and viruses are the most common disease-causing microorganisms, and they are invisible when they first damage the plant. Only at a later stage does it become visible to the naked eye, and it affects entire plant components. Traditional methods for detecting plant disease necessitated a significant amount of time, extensive research, and continual farm monitoring. However, because to technology advancements in recent years, farmers have been able to find optimum solutions that have resulted in higher yields. Artificial intelligence is rapidly growing field that can be used to automate tasks and increase efficiency in a variety of industries. It was also used in the agriculture industry to boost crop productivity by detecting and classifying diseases affection early on. As a result of taking precautionary measures, the disease has been affected, preventing the spread of the disease to other plants in the field. As a result, image processing on computer vision makes this possible, as well as training the convolutional VGG19 architecture was used to create the model to find the disease by uploading it in the model input for its well-known range of therapeutic effects. Here is the keywords we used in this project. VGG means Visual Geometric Group. Keras, it is one of the Python library. Google Colab, it is an execution of the various types of codes, and CNN is a convolutional neural network. List of the figures we used in this report. List of the acronyms and abbreviations. CNN, Google Colab, VGG, table of contents. Chapter 1, Introduction. In India, the agriculture is a major source of the income. The agriculture sector employs the majority of country's people either directly or indirectly. As a result, creating high quality agriculture yields is essential for the country's economic progress to continue. Farmers choose the proper products by monitoring and maintaining the necessary temperature, light, and humidity needs in order to generate harvests of higher quality and productivity. Furthermore, due to population expansion, weather fluctuations, and political instability, the agriculture business has begun to explore for new ways to enhance food production. Farmers are still grappling with issues such as early detection of plant diseases because observing the sort of disease on the plant leaves with the naked eye is not always possible. An automated expert system that can help detection the disease in a timely manner would be very valuable. Advances in technology, particularly the use of image processing in conjunction with a machine learning technique, will aid farmers in detecting plant disease in its early stages. Turmeric is a dried rhizome of Curcuma longa, a perennial herbaceous plant in the Zingiberraceae family. Turmeric contains up to 3% of curcumin, the most physiological active phytochemical component. Due to its high curcumin concentration, India turmeric is regarded as the greatest in the world. It extracted and studied for its well-known medical properties. The creation of an automated system for turmeric disease classification is motivated by the goal of integrating the information and communication technology (ICT) with agriculture sector. Leaf spot, leaf blotch, and rhizome rot are the three diseases that damage turmeric leaves. Each of these diseases has its own cause and symptoms, which are listed below. The turmeric leaf spot is the most common disease that affect the plant. It has a key stumbling block to successful turmeric cultivation. Brown dots of varied sizes emerge on the upper surface of young leaves as a symptom. Collectotrichum is a fungus that causes it. Small, oval, rectangular, or irregular brown spots emerge on the either side of the leaves as a symptom of leaf blotch disease, which quickly turn filthy yellow or dark brown. The fungus Taphrinum maculans is the culprit. This disease is caused by the fungus fighting Graminia column. Turmeric plant byproducts are utilized in food preparation and health care on a regular basis. The most frequent turmeric plant diseases are leaf spot and leaf blotch. VGG19 is a CNN convolutional neural network architecture used for strict picture classification and detection. And here is our aim of the project. The aim of our project is to detect and classify the disease in turmeric plant through image processing using VGG19 architecture. The main aim is to identify diseases in turmeric plant, and our project domain is the timely identification and early prevention of a crop diseases are essential for improving production. In this paper, deep convolutional neural network CNN models are implemented to identify and diagnose diseases in plants from their leaves. Since CNNs have achieved impressive results in the field of machine vision, standard CNN models require a large number of parameters and higher computation costs. In this paper, we replaced standard convolutional with depth-separable convolutional, which reduces the parameter number and computation costs. The implemented models were trained with the open dataset that consists of 14 different plant species and with 38 different categorical disease classes and healthy plant leaves. To evaluate the performance of these models, various parameters such as batch size along with dropout and different numbers of approaches were incorporated. And the scope of our project. The scope of our project is to get the accurate values of the disease using the data set we use and find what type of disease the leaf is having. And the literature review.
The literature review of this project is we have taken from 2020 2019 papers. Yeah, the author of this paper is Vignesh Sharma, Amandeep Vemla, and etc. The title of this paper is Classification Techniques for Plant Disease Detection. The summary of this project is techniques to classify plant disease with CNN approach with ANN, CNN, SVM got associated nursing model accuracy of 86.9, higher than that is necessary attribute for the economic process of any country. The agriculture sector provides employment to several people and accounts for major portion of gross domestic product in several countries around the world. Therefore, for increased agriculture productivity, the detection of plants and associated in nursing early stage is quite vital. The normal approaches for malady detection in plants need extensively quality of the time, intense analysis, and also the constant observation of the farm. However, optimal solutions are obtained over the past few years because of technology advances that have resulted in higher yields for the farmers. Machine learning and also the image processing squared measures typically won't to find the malady on the agriculture harvest. The image process steps for disease identification embrace deeper features, pre-processing, segmentation, and high extraction. Within the top within the top of this review paper, we have a tendency to rely centered on the foremost user classification mechanism in malady detection of plants like convolutional neural network, support vendor machine, k-nearest neighbor, and artificial neural network. And the second paper is from 2017. The authors are Prem Sudha, and the title is Future Selection for Techniques for the Classification of Late Disease in Turmeric. To spot plant disease in pictures from the crops by a future choice and CC, the plant system shows the classification of turmeric leaf disease victimization support vector machine folded with data gain provides high accuracy of 93.75. When put next to alternate algorithms, the planned work involves future choices and machine learning techniques to analyze three sorts of disease in turmeric, specifically leaf spot, blight, and stalk rot. The work comprises three future choices techniques like PCA, information gain, and relief attribute. Authority combined with the classification SVM Navy, Thomas Bayes, and decision trees. Performance analysis of this plant system shows the classification of turmeric leaf disease victimization support vector machine pooled with data gain provides high accuracy of 93.75 and compared to alternate algorithms. And the third paper is of 2016 and the authors are Marco Arsonic and Andrew Sandrella. And the title of this project is a deep neural network based recognition of plant disease by leaf image classification. The paper is bothered with the replacement approach to the development of disease recognition model, support leaf image classification by the use of deep neural networks. Uh, a deep framework developed by Berkeley's Vision and Learning Cave was won't be the performance the deep CNN coaching. The experiment results on this developed model achieved preciseness between 91 and 98 for separate category test on an average of 96.3. The project description, the second chapter is project description. Existing system. Turmeric is blocked by numerous diseases throughout its growth model. Not find its disease in the early stages might result in the loss in production and even crop failure. The foremost necessary issue is to accurately establish diseases of turmeric plant rather than treatment multiple steps like image preprocessing, future extraction, and have classification within the standard methodology. To enhance the detection accuracy of turmeric disease, a deep learning neural network technique has to be involved. YOLO3 tiny model is planned. To improve detection accuracy than YOLO3 tiny, this methodology uses residual network structure support the convolutional neural network, especially layers. Moreover, this experimentally shows the cycle GA and augmentation method on turmeric leaf data set support a lot for improving detection accuracy for smaller datasets and also have planet model has associated nursing advantages of high detection accuracy and fast recognition speed compared with existing traditional models. The proposed model compared to alternative models like YOLO 5 and one alternative model, the model we have tendency to square measures proposing offers a better result and correct results. The model we have tendency to propose is the model that works on which is in internet which is 16 design. We have a tendency to square measure victimization Google Colab because of setting. We have a tendency to square measure given dataset as pictures like the T pictures and that we have processed the unwellness as leaf spot and leaf blotch. The 15 pictures contain leaf spot and another 15 contains leaf blotch. Feasible study. All you wish could be in internet associated and the camera equipped cellular telephone. The well-known business applications I naturalist and plant span shows however this can be attainable. Each app standard sharing skills with customer additionally as building initiative online social communities. In recent years, deep learning has semiconductor diode to nice performance in various fields like image recognition, speech recognition, and tongue process. Convolutional neural network is recognized because the best technique for seeing. We have a tendency to contemplate the neural design specifically quicker region-based convolutional neural network, regional-based convolutional neural network, and single-shot multi-box detection SST. Pre-processing of image is extremely vital to models for correct processing. Several infections like viral fungal typically will be is maybe adverse to differentiate often sharpening overlaps symptoms. Technical feasibility. Through investigation exposes the capability and limitations of this model. Overall, once validation is an extremely controlled setting, an accuracy of 97.2 sharing is given. This achieved accuracy depends on variety of things including the stage of malady sort, background information, and object composition. Because of this, a collection of user points would be needed for business use to make sure the expressed accuracy is delivered because the model was trained employing a plain background and singular leaf imitation of those options is best. Social feasibility.
Social feasibility, augmentation and transfer learning during this case proved beneficial to the model, serving to the CNN to generalize a lot of reliability, whereas this improved the model's ability to extract options. It had been not enough once the model was presented with in-field imaging During this case, the classifier ranked associate degree accuracy of simply 44 portions the importance of diversifying the coaching dataset to incorporate alternative background knowledge, extraplant anatomy, and varying stages of disease. Overall, this study is conclusive in demonstrating how CNN is also applied to empower smallholder farmers in their fight against disease. Within the future, work to be targeted on diversing coaching datasets and additionally in testing similar internet applications in real-world things. Without such developments, the struggle against the plant diseases can continue. And here we need the system specifications. Our hardware specification system has to be 64-bit operating system and 64 processor. And the software specifications are 4 GB RAM and better GPU, 2 GB graphic card around. And here the standards and policies of our project. Google Colab. If you have got used Jupyter Notebook, you'd quickly learn to use Google Colab. To be precise, Google Colab could be a free Jupyter Notebook surroundings that runs entirely within the cloud. Most significantly, it doesn't need a setup, and therefore the notebooks that you just produce will be at the same time amended by your team members. Just the manner you edit documents in Google Colab. Colab supports several standard machine learning libraries, which might be simply loaded in your notebook. As a programmer, you can perform the following using Google Colab. Write and execute a code in Python, document your code that supports mathematical equations, create, upload, share notebooks, import, save notebooks from to Google Drive, import, publish notebooks from GitHub, import external datasets like example from Kaggle, integrate PyTorch, TensorFlow, Keras, OpenCV libraries, free cloud service with free GPU. VGG, Visual Geometric Group. AlexNet came moved into 2012 and it improved on the normal convolutional neural networks that therefore we will pursue VGG as a successor of AlexNet. However, it had been created by a unique cluster named as Visual Pure Mathematics Clusters at Oxford and then hence the name VGG. It carries and uses some components from its predecessor and improves on them and uses deep convolutional neural network layers to boost accuracy. Let's explore what VGG19 is compare and it with a number of opposite versions of the VGG design, and additionally we see some helpful and sensible applications of the VGG design. Before diving in the looking out at what VGG19 design is, let's take a glance at ImageNet and a basic information of CNN. Chapter 3. Here is a methodology and the general architecture and the architecture of our project, VGG19 architecture. The architectures of convolutional neural network have not stopped evolving since 1989. The optimization of criteria and parameter serialization, classification, and structural reformulation present a continuous evolution. Moreover, a good number of these improvements are focused on the restructuring of the processing units and design the new blocks. And here are the design pieces, data flow diagram. First, we should give the input images, next then train data and VGG19 train model. And here we go to test data, and it classifies what the disease is, leaf spot and leaf blotch, and finally it gives the result to the user. Use case diagram. When we give a new input, first the module extracts the leaf features, then it goes through a CNN model. It then compares the feature with already trained dataset, then it goes through dense CNN and leaf features are extracted separately. Then the module will predict whether the plant leaf is affected by disease or not. It shows the output from one of 38 classes which are predetermined and trained. Then the output will be in the textual format. Class diagram. And here is the class diagram. The normalization class comprises of raw image and it is feeded the CNN model which comprises of dense and wide. The CNN model classifies and detects by using the training model. The training model class comprises of the image dataset. Leaf detection gets use of features. Sequence diagram. The sequence diagram for the model gives a perfect sequence of data. These diagram gives a clear idea of how the data passes to the next step and explains what steps are linked together. Collaboration diagram. And this is a level 0 collaboration diagram, and this is the level 2 collaboration diagram. And here is the explanation for those collaboration diagram of our project and activity diagram. Here we can see the flowchart of activity diagram. User uploads the VGG19 or 16 architecture and uploads the test image, and this test image goes through the CNN architecture and detects the which disease was affected by the leaf. Algorithm and pseudocode. Algorithm. As the steps we wrote here, open Google Colab and select to the next new notebook. Next, connect the Google Drive to the Google Colab to import the dataset. Install the required libraries needed for the program. Next, import required libraries like Keras, Pandas, Mat, Plot, Lib, Image, Data Generator. Step 5. In the sample data, create train data folder. Create 2 folders in the train data and name them as leaf spot and leaf plots. Upload leaf plots dataset and leaf plot dataset in the respective folders in the train data. Upload a test image in the train data 15. Name the test image as test image. Run the respective code in the respective fields. Plot the training and validation accuracy values, loss values. Based on the accuracy model, we will test the input image with a high accuracy value. Last step, model will be predict the output as leaf spot or leaf plots. Pseudocode. Import the numpy library as np. Import the library pandas. Import the matplotlib pilot as plt and import os. Import keras libraries. From the keras preprocessing image, import the image data generator. Convert the image to array and load the image. Import the VGG19 from the keras applications.csv files for train and valid data. Label the train data as an image data generator and give the zoom range, share range, horizontal preprocessing function. Label the train as train data gen flow from the directory and give the direction of the train data. The above code generator generates how many images belongs to respective fields. Define the plot image as image array and label. Give the figure size to the plot image. Clipping input data to the wide range for show with RGB data.
Modules. Image acquisition. This is a strategy of getting photos with a camera by visiting the placement or victimization different available resources like image databases or line repositories. The pictures are taken in 3 colors: red, green, and blue. That a color transformation structure is generated and device independent color area transformation is applied. Image process pre-processing is when the data is given to the dataset, the image will be pre-processing and gets trained from this image processing. Image classification is the method of segmenting pictures. It's completely different classes supporting the features. Features may be the parameters in a picture, the element intensity, the amendment in element values, and many more. We are going to attempt the pursue these elements shortly. For the nowadays, the picture belongs to a similar individual but varies when compared across options. Just like the color of the image, position of the face, the background color, the color of the shirt, the penalty of addition, the most important challenge once operating with pictures is the unnecessary uncertainty of these options. To the human eye, it's all similar. However, once regenerate to knowledge, you will not find a particular pattern across these pictures simply. Image segmentation. Image segmentation is done employing a form of approaches such as boundary and spot detection algorithm or an area detection algorithm program, their thresholding and edge-based strategies approaches like k-mean clustering and so on. Network in network layer, a pooling operation, a large size convolution neural network and smallized convolution neural network, which is 16. This Google's network won the 2014 ImageNet competition with an accuracy of 93.3. It's composed by 22 layers and in a recently introduced building block referred to as organization module. Steps you execute, run, and implementation of project. Upload the INPYB code in the Google Colab project. Create and upload the dataset and run the code in the respective fields. Implementation and testing. This is the dataset of one disease like leaf spot dataset, and this is a leaf velocity dataset, and this is the output of the accuracy of VG16 and VG19 architecture. This is the output for testing an image that we don't know what type of disease the leaf has got. These are types of testing, like unit testing and integration testing, system testing, and test result. This is a test result of whole project, and results and distribution. Efficiency of the proposed system. We can predict the category for brands ranking new knowledge instances victimization and our finalized classification model in Keras using the prediction path operate. Note that this will operate is measurably accessible on consecutive models, not these models develop victimization, the practical API. There, the output defined are going to be the malady is the train model can be analyze the input with the info pre-train and build a prediction. We got 99 point accuracy with the input, but with discomposed knowledge, the model might not be correct, but the accuracy stays between 96. VGG16 versus VGG19 architecture and loss comparison. The predict the category for brands ranking new information instance victimization. The finalized classification models in Keras victimization the prediction path perform. Note that this perform is just offered on sequence models, not those models developed victimization the practical API. There the output defined are going to be the unwillingness is the train model with VG16 architecture can be analyzed the input with the information pre-trained and build a prediction with prediction. We got 94.5 accuracy with the output, but with decomposed information, the model may not be correct. But the accuracy stays between 93 and 94. The trained model with the 1619 architecture with the information pre-trained and built a prediction, we got an accuracy of 97.222. Here the VGS19 model has the whip hand with 97 point C accuracy with steady results as we tend to observe this graph. This is a sample code for our project, and this is output where the image is being tested. Yeah, this conclusion. This is the conclusion of project. The maximum current paintings have been tested and illustrated. It may be said that some of the techniques utilized with inside the preceding paints, the deep studying principles, especially the Syrian approach, have received the highest accuracy. Future enhancement is this have a look at the proved prevalence of RPG discipline picks in which the type accuracy became maximum for two illness. Surprising it additionally furnished a competing accuracy with inside case of pictures indicating with VG16 and VG19 performed well than VG16 SVM and LX hence VG19 is proved proposed to this project. And this is the plagiarism report. We got 87 unique, and this is a source code for our project. This is poster presentation. These are the references. So the execution for this project is open the Google Colab in the Google and upload the VGC19 final architecture in this Google Colab. So I'm uploading the VGC19 architecture in this Google Colab. So when the upload is completed in this Google Colab, it will show like this. So on the left side of this column, you might see the file section. So go to the file section. And in the sample data, you have to create a folder. The folder name is train data. So after creating a folder in sample data, in the training data, you have to create another two folders. Leaf, leaf spot, and the other folder is leaf plots. So after creating two folders in this train data, you have to upload the dataset in the respective folders. So we will try to upload this dataset of the leaf plots in this leaf plot section. So this is the data of leaf plots. So this is all the images. So I'm uploading all the images. So it's taking some time to upload. You can see here. And again you have to upload this leaf spot images in the leaf spot section. So we will try to upload there. This is the dataset for leaf spot. After the completion of this uploading, so you have to upload a training data like the image that we don't know what type of disease it is. So we are uploading the image, one image. So you can see here a test image that is uploaded in the training data. So we will execute each section in the code. You can see the code is running here, and when this tick comes, the green tick comes, it means this code is executed successfully. So when we will try to execute another section, this is the path of this is the exact path we have to uh, create these folders with respect of this. So this is the plot image of every image. So you can see here different sets have been okay. You can change the color also here if you need it. Yeah, it is also successfully completed. You can see here the execution is completed successfully. Yeah, this may take some time. It is learning from the dataset given here. So it is this model is getting trained by this dataset from these two folders. Yeah, you can see this is also successfully executed. So this is the default graph for this accuracy and validation accuracy of VGC19 architecture. And this is loss versus validation loss of VGC19 architecture. It's outline, not executed one. This is the prediction part actually. This is the prediction, and this is a section where the test image has been uploaded here. So when an image is given to this folder, this code, so it uh, it predicts what type of disease the image has got, like the leaf has got. So we'll try to find what type of disease this image has got. So we have to copy the path here, and we have to paste the path here, and we have to enter. So it will show the image, sorry, the leaf code is the leaf, this is what is leaf codes. And loss for this accuracy is 7.66. Yeah, here you can see the accuracy, actual accuracy. So this blue line indicates accuracy of VGG16 architecture, that is a previous model, and this red line indicates the VGG19 accuracy. So you can see a vast difference between these two accuracies. So from this we can see that the VGG19 has some better accuracy than VGG16. Yeah, here you can see the VDG loss. Actually, VDG loss 16 loss is some, yeah, it's more, but when compared to VDG 19, the VDG 19 loss is better than VDG 16. So by this we can find what type of disease the leaf has got, and accuracy between VDG 16 and VDG 19. Yeah, thank you.